So this is just sort of a sub-lesson here talking about increasing, decreasing, and constant behavior of functions. We talk about domain and range from left to right, right? We talk about domain specifically from left to right, range from bottom to top. But domain we talk about from left to right. We're going to talk about the increasing, decreasing, and constant behavior of a function the same way. From left to right, is it decreasing, is it increasing, or is it constant? We could think about the slope. So increasing would be a positive slope. Decreasing would be a negative slope, and constant would be a zero slope. If we talk about our mountain man that we talked about earlier this unit, if the mountain man is climbing up, it's a positive slope, he's increasing. If he's climbing down, it's a negative slope, he's decreasing. And if he ever hits a plateau, it's a zero slope. So on this graph, if we're trying to figure out where is it increasing, decreasing, and constant, we're going to write our answers in interval notation just like you would with domain and range. So it starts to increase here, right? It's going up, and it stops increasing right there. And I'm looking, it stops increasing right about there. So our increasing, it's increasing everywhere from 0 to 40. We're always going to use parentheses with increasing and decreasing and constant because at that point where it changes, it's not really increasing anymore. It's not constant yet, but it's not really increasing anymore. Where's it decreasing? So essentially, where is the man going to be walking downhill? Where's the car going to be rolling downhill? It's decreasing from there all the way to there, right? If this was a slide, you'd be sliding down from there to there. And that looks like it's from 120 to 160. So it's decreasing from 120 to 160. And then the final question, where is it constant? Where is it flat? It's flat from there to there, this purple region. It's perfectly flat. That's from 40 to 120. Let's see another example of this. Where is this one increasing, decreasing, and constant? You can have more than one interval for each, but let's label it the same way. Where is it increasing? Is he walking uphill? Nope, he's walking downhill. He's walking flat. He finally gets to a point where he's increasing from here to here. And that's from 2 to 3, right? So it's increasing from 2 to 3. That's the only place where he's increasing. Where is he decreasing? He's actually decreasing all the way from here to there. That's from -4 to -1. And then he's also decreasing from here, and it looks like that keeps on going. So from 3 onward. So from 3 all the way to infinity because that arrow points to the right. Notice I put the U in there for union just like we did when we were talking about intervals with absolute value inequalities, other types of inequalities, domain, range. We have two separate intervals, right? We have two separate of those yellow intervals, so we need to connect those with a union. And where is our function constant? Where is it flat? It's flat from there to there. That's from -1 up to 2. And so that is our interval. That's the only place where it's constant. One final example here, one final idea here. If we want to ever find the relative maxima and minima, relative maxima and minima are the highest and lowest points of the graphs that are not including infinity, right? We're talking relative to the little box of information that we have here. If this is going off towards infinity, obviously the maximum is way up there at infinity, right? We're talking about not the maximum. We're talking about the relative. Relative to what we can see, what's the maximum? Relative to what we can see, what's the minimum? And so looking at these points, they're always the points where you turn around, right? So this goes down and it hits a little minimum there. It goes up, it hits a little maximum there. It goes down, it hits a little minimum there. So when we talk about maxima and minima, we can talk about the location of the maxima and minima and the value. The location is always the x value, and the value is always the y value. So here, the location of the maxima, we go down, we finally come back up, we peak. That's the maximum that it gets, right? That's the maximum that it gets in that little range of the graph. So the location is at x equals 2, and the value is y equals 1. The value, you could say equals 1, or the value is y equals 1. How about for the minima? We go down and we hit a bottom here, right? We bottom out right there. That's a very, very minimum. So the location of that is at -1. Of that minima is at x equals -1. And the value is either -5 or y equals -5. I keep putting an extra equal sign in there that I'm not intending to. There's another minima over here, right? The location of that minima is at x equals 4, and the value is y equals -2. And that's it for increasing, decreasing, maxima, minima. That's all you need to know for this class.